Thank you so much. Good morning. How are you? It's good. It's early in the morning. We have some good competition in the other room from Julian Story himself. So nice to be here. This is sort of what we will cover in the next 45 minutes or so. And this talk is, to a large extent, it's the story of me finding out that there is such a thing as immediate mode GUIs and my adventures in trying to use them in an audio plugin. It's also an excuse to talk about threading, window managers, message loop, and all the sort of things that goes on under the hood of a graphical user interface. My intention is that even if you don't end up using any immediate mode GUI, you should still come away feeling that you've learned something about how GUIs are built. So let me introduce myself. I'm Gustav Andersson. I'm a software engineer based in Stockholm, Sweden. I work for Elk Audio, and we make the Elk Audio OS, which is the fastest way to get your plugins running on hardware. If you're interested, come talk to me afterwards. At Elk, I worked a lot on the plugin APIs, mainly from the host side. I worked on the audio engine, basically building a DAW. I'm interested in C++, performance, sort of where the rubber meets the road, play the guitar, synthesizes, currently have some sort of obsession with old 80s, 90s rack gear and trying to make some feedback ambient from them. And there'll be some code example in this talk, mainly C++. I've tried to make it as much platform agnostic as I can, but in the case of where there are OS-specific things, I've chosen Windows because that's what I'm most used to in that area of programming. I'll also take the opportunity to recommend you to use some kind of cross-platform library to try to abstract away all the OS-specific things, but because sometimes that's not really that fun to work with. Back to this talk. I want to understand the background for it. I want to throw out two concepts that I think are kind of crucial for understanding the background and motivations behind doing something like this. I'll give you a minute to read, but I'm pretty sure most of you have seen this before. And to be honest, isn't this like 90% the reason we even write code? Like, we could use a library. It's often the same thing to do, but we have this itch, right? I could do it myself. Like, how hard can it be? And being Swedish, I think the IKEA effect is maybe not the best choice of name. Like, my IKEA furniture would be the first thing to go in a move. I don't really care much for it. But you kind of get the point. It's like sometimes we tend to put higher value on things that we built ourselves, and sometimes too high value. So I said professionally, I worked a lot on the hosting side of plugin APIs. But I've always had this idea that I wanted to do a plugin myself. So a few years back came the KVR Developer Challenge, and I had some ideas that I toyed with, and I thought, this is the deadline I need to put something together. So the thing I tinkered with putting together was this. It's an old guitar pedal that used to belong to my dad. And it's like a two-part pedal. One part is an odd envelope filter, but the other is the soft distortion sustainer, which is this interesting combination of a compressor and an overdrive. And it has this kind of very sweet bluesy tone when you play it on guitar that I've never really heard anything like it. And I thought, there's a million overdrive and compressor plugins out there, but maybe there's a tiny niche here that I can fill. So that was my starting point. I had like 2.5 months to go, something. Had a bunch of pieces already. I had started working on a plugin wrapper, and for reasons mentioned, I didn't want to use JUCE. But there was a big part missing, which was the GUI. And writing a GUI framework myself in 2 months with no prior experience in my spare time was not something I was going to do. So I needed to find a library. And I know that the general trend in GUIs seems to be towards using more of web technologies and kind of bridging the gap between what is a web application, what is a native application. But I wasn't really interested in putting a web browser in my plugin. And since you are here, I guess you are not either. Otherwise, you would be in the other talk. But and things like bitmaps and film strips, I mean, they lend themselves very well to doing photorealistic GUIs and skeuomorphic GUIs, but I was more into like minimalism and sort of letting computer GUIs be computer GUIs. So with that down, and this is so just my plugin GUI inspiration board to get a sort of idea what I was looking for. But having understood this, I was able to compile like a rough list of requirements for what I was looking for. It should be something reasonably minimal. It should be vector-based because I felt that being able to resize the window to different screens and resolutions was felt like a big requirement. It should be easy to make your own sort of feel to it. And I think audio plugin GUIs are kind of interesting from a design perspective because they live in their own little world. Like they're not expected to conform to the expectations of like a native OS app. But being able to like draw your own knobs and sliders and stuff was a big requirement. It should ideally work with CMake and be like native C++. And eventually I discovered, and when I was looking for this, apart from like the big monoliths of Qt and WX widgets and stuff, there was a whole class of other like minimalistic GUI libraries they came mostly out of the gaming scene. Some of them were more full-featured than others, but many of them used this API paradigm or API style that was known as Immediate Mode GUI. And that got me interested. And it really sort of appealed to me. Like find that the APIs were really expressive and they had this outspoken minimalist philosophy to them. So there was a completely new take on GUI programming to me. So I thought, why not give it a go? And surprisingly, it didn't seem like it had been talked about much in the audio world. Like I've been to, I think it's my 6th ADC or something, and I've never heard a talk. 7th, all right. I've never heard a talk on it. I've never really talked to anyone about it. I did a search on the JUCE forum for Immediate Mode GUI, and it's like 5 hits or something. So this seems to be a bit of uncharted territory. So you're obviously wondering what it is. I mean, in a few slides, I'll show you some code, but just recap the history a little bit because I read up on it. And the name was coined by Casey Muratori for a GUI for a game engine that he was writing. And in 2005, he did a video on YouTube trying to explain the concept. There was a zero memory widget, was another early implementation that was similar but didn't use the name. But the name itself is a nod to immediate mode graphics, like OpenGL, where you draw directly by calling functions, like calling a function, draw a line, draw a circle, etc. And kind of applying that to graphical user interfaces, like draw a button, draw a knob, and process what's done with it. And the framework that I settled on the library is called Dear ImGui, because I felt that that was the most sort of mature and well-maintained project in the genre. So what is it? But I think to explain what it is, you kind of need to put it in perspective and contrast it towards how traditional GUIs are built. And before I discovered Immediate Mode GUIs, I thought the way traditional GUIs were built with objects and objects having callbacks was just how GUI frameworks were built. So they use by having, so everything is like a widget. There's usually a widget base class that everything inherits from. And widgets like a button have a on-button clicked callback that you connect, or you subclass it and override it. And when the button is clicked, your callback gets called, and that's how the sort of the actions happen. And this is, at runtime, this is constructed into a like tree-like structure, and it's usually like the top-level window is also a widget. Sometimes it's called a component, and then the widgets inside it are child widgets of the top-level window. So yeah, how does this look? Like finally, some code. I think everyone was waiting for this, but I've tried to unpack this. What I've tried to make here is like the minimal amount of code needed to get a clickable button in a JUCE-based plugin editor. But including all the boilerplate necessary. So to do that, we need to inherit from not only from the JUCE audio plugin editor base class, but also from JUCE button listener, which gives us this on button clicked callback. We define, and then we need to have space for the actual button widget. And then somewhere in our constructor, we need to configure it. So we need to say, okay, we need to set the label for the button. We need to add ourselves as a listener. So when the button is clicked, our callback will be called. And then finally, we need to call add and make visible to display the button. And finally, we need to implement the callback, which will be called. And then we can actually do the thing that happens when you click on the button. So does this make sense to everyone here? Yeah, see a lot of people nodding their heads. So how does this look if we do this with Dear ImGui? Looks like this. Can you sort of see what I fell for? What I thought was, that is really nice. Because there's no objects, there's no callbacks. It's just somewhere in your draw UI code, you call ImGui, : button, you pass the label as an argument, and if this function returns true, the button was clicked, so you do what you do if the button was clicked. This is another example with a window. And notice that the window is really sort of what is between the begin and the end functions. And you can kind of nest these also to have windows within windows. I guess some of you are probably asking now, but wait a second here. Doesn't this actually mean that you are continuously redrawing the GUI? And yes, that is true. You are, but we'll see later. It's not such a big deal, actually. And immediate GUIs were usually, they come from the gaming scene, and they were often used to draw like prototype and development GUIs for games. So they would draw on top of the game screen. So it would needed to be rendered at 60 FPS or something. But I think now it's evolved into something that's much more powerful and can be used even for commercial applications. To sum up, like it's all procedural, which means that it's a lot less boilerplate. And you could, I mean, it's optimized for dynamic GUIs because you're continuously redrawing, so it's very easy to just change the GUI, draw something else. There is no sort of state required to, that the GUI doesn't have to retain any states. We'll see later that it might be good to keep some state in the GUI, but the library or the API itself does not require you to store any state in the GUI. You could argue that you're mixing business logic with drawing, and that's a bad thing because of separation of concerns and all that. But I would argue that's actually one of the things I liked about it. Like, to me, it just expresses the program flow in a very like clear and concise manner. It's like draw a button. If button was clicked, do this. Draw a knob. If knob was turned, do this. If mouse over, just show help menu, etc. And it's stack based instead of this parent tree structure. So, quick example of if you want to do write a headline with a different font and a different text, you would just push a font and push a different color to the stack, and then the text you render will be with that font and color, and then you can pop it from the stack. Oh, sorry, and then the way you interact with widgets is there's a bunch of these: is item clicked, is item active, is item hovered, and these always refers to the last item that you draw. So that down, we've talked a little bit what an immediate mode GUI is and how it works. I think before we're getting into the technical bits of integrating it, we need to take a little bit quick step back and just look at how computers actually draw on the screen, what is a message loop, and things like that. So this is easy, right? You just put some bits on the screen. Like, how hard can it be? Or you write to some register. In the early days, that was basically what you did. Just for fun and context, like in the very early days, computers were very limited, and you couldn't even store the whole image in memory, so you had to kind of construct the image as it was being scanned out by the sort of electron beam of a CRT television. And a lot of it was like hardware, like the text was hardware, all the moving things were sprites that were done in hardware. And people did some crazy stuff with this, and a lot of those, like pushing the limits of those machines, relied on that you could sort of know the position of the beam on the screen. So you had to program in sync with how the image was displayed. So computer got more powerful, and then this, with 3D games, this changed into sort of rendering the whole frame in memory before it was being displayed on the screen. And this led to a scheme called double buffering, where you would draw on one buffer, while the other buffer was being scanned out and displayed on the screen. And during the vertical blank, which is when the screen has finished scanning out the last line, before it has started on the first line of the next image, there's a little period there where you can switch the buffers around. And then the screen will start displaying the new image, and the computer will start rendering the next image. So that way you were always synchronized to the sort of screen update rate. Also something like having multiple processes running on the same computer and running, like sharing memory, sharing CPU, sharing I/O was not a trivial thing, but they also had to share the screen, which sort of led to the invention of the window manager, which was a little process that allowed different processes to run in Windows on the same screen. And this is Windows 1.0 from almost 40 years ago. And it had what is known as a tiling window manager, but where windows are side by side. And that means that windows can't actually overlap. And the reason why is because all the windows write into the same frame buffer. So the window manager has to tell for instance, the clipboard window that you get this part of the buffer. You can only write into that buffer. And if you write outside of that, it's a complete mess. So the history of window managers is long and fascinating, but we will just skip to what is the situation today, which is that basically every platform that you will write plugins for today has what is known as a compositing window manager, where every window have their own buffer. So every application will draw into that Windows buffer, and then the window manager will take all these buffers and sort of composite what goes on the desktop. And now you can not only like can windows overlap, but you can have shadows, you can have transparency, all kinds of effects. You can press Alt Tab and you can get like miniatures of all the open windows, and all of that is possible because we have a compositing window manager. And actually, how the window manager does all this compositing is a bit of a rabbit hole, but we don't need to go in too much detail. But a lot of it happens on the GPU. I think that is much high-level information we need. And this is, I think most of you know some bits and pieces, but I want to do like a 5-minute walkthrough of how you do a basic windowed application and how you interact with the window manager. So to create a process or a program running in a window on a modern OS, you need to do basically like 3 things. You create your window, and you supply a window callback, which will be called by the OS or by your message loop when everything happens, like mouse input, keyboard inputs, etc. And then you call get message in the little loop. And what get message does is it takes a message. If there are messages on the message queue, it will take a message and return it. And then you call translate message, which just maps between virtual and physical key presses. And then you call dispatch message. So dispatch message will call the window callback of the window that the message was destined for. And your window callback will probably look something like this. It will be a huge switch statement with a switch for basically every. And these are a few examples, but there are like 100 of them. And everything is a message. Everything that you interact with the OS is a message. If you move the mouse, it's a message. If you press the keyboard, if you move the window around, you resize the window, that's a message. If you drag and drop a file in the window, that's a message too. So that's everything is a message in this case. So this little part here it's like on Windows, this is like your default message loop. And I should also say that the call to get message, when you've emptied the message queue, when the message queue is empty, a get message will block, and it will return control to the OS, which will sleep your thread until there are more messages, and then the OS will post messages to the event queue and wake up your thread. So it's event driven. It's driven by messages. And often if you use a GUI library like Qt or something, this is given for you. Like often you don't write this. But if you use Qt, for instance, you inherit from your Q application, you set up all your widgets and all your callbacks, and you call exec. and everything just works. Because at the bottom of it, if you go into the code and look, you find something like this message loop here. And also, when you load your plugin into a DAW and the host wants to open up the editor window, it will call open also from this thread. Yes. And if you use a cross-platform library like GLFW, you have GLFW wait events, which does this whole little dance. But that's nice. Then you don't need to rewrite it for other platforms as well. And this was sort of the event-driven way. Whenever this events, the OS will wake up your thread and let you do some work. Yes, and even painting the window, like drawing, is done in response to a message. So, and this should be handled separate from control inputs. So, if you get a mouse click event and this is on a button, then you do the action associated with the button, but you don't actually redraw the button immediately if you want the button to be depressed. Instead, you tell the window manager that the part around my button is now outdated, and when you have time, send me a paint event, and then I should redraw the window. But if you look at some of the examples in Dear ImGui, you'll see that they're slightly different, that there's no call to wait events, but instead they have this first they call swap interval instead of to 1, which means that when you call swap buffers later, it should wait 1 frame. And instead they call poll events, and poll events does exactly the same thing as wait events, except when the event queue is empty, it doesn't block, it returns immediately. But swap buffers will swap the buffers and wait for the next vertical sync. So now instead of being event-driven, you're actually being driven by the screen refresh rate. So now you can draw in sync with your window frame rate or and this is sort of what games do, but typically not what desktop applications do. And previously we assumed that any drawing happened directly on our thread in memory. With OpenGL or any other graphics API, now drawing happens on the GPU instead, and you use some graphics API to send commands to the GPU, and which will draw it asynchronously. Thankfully, most of the details are kind of abstracted away by the renderers provided by the library and the window manager, so we don't really need to bother that much with it. So back to GUIs and plugins again, and let's talk about GUIs and audio plugins in particular. So what is special about a GUI running in a plugin instead of a standalone application? Why can't we just take Qt and just shoehorn it into a plugin? So there's basically 3 main issues that you're going to stumble on, and this is not just for Dear ImGui. This is the general case when you have any GUI library that was not built with plugins in mind and trying to take it into a plugin. So these are the 3 main issues you're going to stumble on. The first one is the message loop, because your host already has a message loop. But thankfully, the host is set up so that your editor window will be served by the host's message loop. So what you need to do is just make sure that you don't create your own message loop, and you don't call swap buffers with a non-zero swap interval and something like that. That could block the host's message loop. Because with their ImGui, this was not so hard, because we'll see later it has this split into what is a core part and a front-end part and a renderer part. So it doesn't actually have you need actually to build the message loop yourself. And some plugin APIs are also kind of special. For instance, VST3 don't want you to read the key presses through the window callback. I didn't really work with key presses in my plugin, so no. But I guess the motivation is that they don't want the plugin to mess with the keyboard shortcuts of the host. Multiple instances, you probably want to be able to support the user loading multiple instances of your plugin and also opening multiple windows of the same plugin. So typically most libraries have some kind of static data that you need to either keep separate, or so that each instance has its own data, or you need to share them. And if you want to share them, you probably need some kind of reference counting so that the first instance to open will initialize it and the last one to close will deinitialize it. I should say that there is the main branch of the ImGui does not support having multiple top-level windows per context. So, but there is a docking branch of the ImGui it's being continuously updated and it's been lived on for like, I think 2 years or something. And the aim of it is that it should be merged into the main branch. But that one does support multiple, having multiple top-level windows in the same context. So it's a little bit, either you use a docking branch, which is a little bit more complicated, a few more callbacks to implement, or you use the main branch, but then you need to juggle multiple contexts around. There is a more subtle case that you should be aware of with multiple instances, which is not multiple instances of the same plugin, but if you say that your plugin was really successful, and then next year you want to make another plugin using the same framework that you've now built, then you can run into some issues. And one of them has to do with dynamic linking. Like you need to make sure that if your plugin has dependencies that link dynamically, you make sure that you don't, like the old plugin doesn't link with the new one, or there is backwards compatibility. And I think that the recommendation is to, in general in plugins, to static link as much as you can to make the plugin as self-contained as possible. Specifically on Windows, there is a thing with where you install the window callback. You do this by registering a window class. And this window class needs to have a unique name. And if you use something like GLFW, it has a hard-coded window class name, which means that your second plugin will have the same window class name as your first one, and then you'll run into some collisions there. And I think what JUCE does is basically just generating a unique name every time based on time of the day. And what I did was just similar, just have a name and just add a randomized suffix to it. You can probably use a UID also for this, but I mean, it should be unique across all plugins basically. So if some other plugin maker does a plugin with the same window class name, you're also going to run into issues. The third issue is that typically if you use a cross-platform library like SDL or GLFW, they wrap the window creation. So you call create window and they give you like an SDL window which is a struct, but deep down there's a link to a native OS window. But the way the most plugin APIs are constructed is that they want the host to create the window for you. So then you get a reference or a pointer to what is a native OS window. And then you end up in a bit of a situation because I wanted a GLFW window, but I only got a Windows native window. So the reason most people solve this is actually you create your own window anyway. And then you take your window and you reparent it to the window you got from the host. So basically you put your window as a child window inside the window you got from the host. And it should be the same size, so it completely fills that window. So it's one window within another window. But typically the user doesn't see this. But underneath it's actually two windows. But there's also leads to when you want to resize the window, there's a little dance you need to do with the host. You need to tell the host, okay, call the resize function. Then the host will call the resize function. Then you need to resize, and then you need to do a little bit of back and forth there. But that was the general case. Then looking at specifically integrating a specific library into a plugin. And this is Dear ImGui. And it consists of like a core part, which takes in control events and it outputs vertex buffers. It has no dependencies apart from the standard library. So it's very like self-contained and platform agnostic. But in order to use it, you need to pair it with first a control frontend that gives you mouse and keyboard inputs and a renderer that translates these vertex buffers into something that the graphics API can read. But the repo comes with a bunch of reference or example implementations that you can use. So most of the time, you don't need to bother writing these front ends and renderers. Sort of a digression here on the topic of this architecture split. At Elk, we've toyed a bit with this and felt that this could be an attractive UI for embedded devices, because on embedded devices, you typically don't have a window manager because it's a big and heavy process. So on Linux, meaning that you don't have an X server, but instead you have direct access to the frame buffer. But with this three-part architecture, it's really only like the front-end part that depends on the window manager. And if you have a device like a synthesizer that has buttons and knobs instead, you probably need to rewrite that part anyway, because you're not controlling with a mouse and keyboard. But the other two parts should really be quite easy to integrate. And we've experimented a bit with this, and it's looking promising. CPU load could be an issue, but I mean you could change the refresh rate, and you can typically also the GUI, the CPU load is quite consistent because you're continuously redrawing it, so you can kind of factor it in and work around it. Yeah, my first attempt to do this, I thought it was pretty smart, but eventually it failed. So I used GLFW for all the window handling, and I had a static counter for initializing and deinitializing the library. And then I thought I'd just try to keep everything separate. Like each window should be its own self-contained instance. So my idea was to start one thread per instance and then have the ImGui context as a thread local variable. So they would all be independent. They would not know about each other. And this worked quite well on Linux and on Windows. But then I tried to take it to Mac, and failure, because on Mac it's only the main thread that can even create a window, and it's only the main thread that should ever access the message loop. So I thought long and hard about this, or I thought 5 minutes at a time for a long time. But I landed in that there's only two ways you can do this, basically. And one is you don't create any threads, so you do everything on your message loop, all the drawing, all the event handling. Or you create a render thread, as I did, but you still need to handle all the messages on the message thread, and then you kind of pipe them through some sort of queue to your renderer thread. And then you would need some locking or syncing when you're drawing and when you're creating and destroying window. So the first one, I mean, which one you choose depends a little on your requirements. But the single-threaded version is it's easier to reason about because no threading. Basically, you don't need much locking because it's all single-threaded. But what you need is something that calls you periodically on the message loop. Like if you want to do it at 30 FPS or something, you need something that calls you at every 33 milliseconds or something. And this is on Windows and on Mac, it's easy to set up this. You just create a timer, an OS timer. On Linux, this is a bit more difficult because there's no function in the X API to actually create this kind of timer. And what people do when they need one is that they basically hack the message loop or the select call that's at the very low level. And in a plugin, you can't do it because you don't have access to the host's message loop. So then you need to rely on the host actually giving you something. And some plugin APIs have functions that basically tell you that can give you the same kind of timer API. But the downside of this is that you're not in any way synchronized with the screen refresh rate, and this 30 FPS is something that you require. It's not guaranteed to be anything stable. They could be jitter, and so animations could be laggy. They could be jitterish. Could be, yeah. So if you want really like nice and smooth animations, you really need to draw in sync with your screen frame rate. So then you need to create a separate render thread, and in that render thread you will use this that we saw earlier. You will set the swap interval to 1, and then you will wait for a screen refresh using swap buffers. But you still need to handle all the messages on the main message thread, and you need to pipe them through some kind of queue. And this, you need a bit more locking so that you don't, so they don't end up having race conditions when opening and closing windows or doing that while you're rendering. And this is the approach that I've been aiming for, and I've been working on it a bit. But one of the issues that I ran into is that the reference GLFW frontend that comes with their ImGui is not really meant for this. It's not meant to be called from different threads, and it does a bunch of function calls that are not supposed to be, that are not thread safe, basically. So it needs a bit more work and a bit of rewrite of the front end. Yeah, I want to say something about the state from a plugin perspective. Like this slider float, this is the signature of the function that draws a slider, a vertical slider or horizontal slider in the ImGui. And the V argument is a value. It's a floating pointer, but it's also an input-output parameter. So this is the value that will be displayed. But if you click and drag on the slider, this value will change. So you can use it to point directly into the data model, so that the GUI can directly change things in the data model. And this might be really cool for prototyping, for development, for getting things to run quickly. But for an audio plugin, for a number of reasons, this is not maybe the ideal case. You want to synchronize with the host. You want the parameters to be consistent across a process block, etc. So the solution is to keep some state around. And what I did was keep basically a copy of every parameter value, and it was only like 10 parameters something, and together with a dirty flag for every parameter, so that you would know if you needed to reload it from the data model. Say something about this. I mean, some people often point out that, okay, immediate mode GUIs are inefficient because you're constantly redrawing. And that's, I mean, it's true, it's the default case, but you don't actually, if there's no animations and there's no interaction, you don't need to draw. So you can easily set it up to not draw. There's also a built-in event queue, so you can run it at a low FPS. But there's no support for partial redraws. I mean, to do any kind of work or interact with it, you need to draw it. But I mean, I've benchmarked this against the example JUCE GUIs, for instance, and the CPU load is kind of even lower for those when they are animating. But you can also see it as you've basically paid the price for animating every single item in your GUI, so you can animate anything. It doesn't cost you anything more. A few points about, so I managed to integrate it, a few points about make it look sort of the way I want it to. This is the demo window. Like, if you're interested, I really encourage you to like clone the repo, build the demo, and test it. And this contains like all the widgets that are in it. But it kind of had this, it has this look and feel to it, which is very, very much a vertical layout. And I wanted a horizontal layout in my plugin. And the layouting functions aren't the best. So what I did was just go for a straight, like, fixed layout, where I just place things where I want it to be. I don't use any automatic layouting. Or this was the resulting GUI. But what I found was a good pattern was just to divide it into high-level blocks that sort of, you pass them their X position, and then they return their X position plus its width, so it's easy to chain it. And this took me about 1 or 2 nights to write. It's about 500 lines of code. It's actually quite simple quite easy to read, I think. So this is the layout pattern that I was talking about. You could use position X as an input-output parameter. I thought it was more expressive to take it as an argument and return it. I want to say something about how their ImGui handles fonts and text, because I think that is one of the weakest points of the library. Because it's designed to render on the GPU, what it does is it takes all the glyphs, like all the characters of a font, and renders it to a big image, and then uploads that as a texture. So then every letter is just 2 triangles with a texture on it. And everything is done on GPU, and it's quite efficient, but it has a few drawbacks. And one of them is that the rasterization is not as nice as in software. So especially for the small fonts, they can look a little bit blurry. And to the window manager and to the OS, the text now is just an image. So screen readers will have a hard time understanding this. So it's not good for accessibility, for instance. If you want to write custom widgets, there's 2 ways to do this. Either you use only the public API, or if you use the internal API, there are still a few functions you can use that sort of keeps the behavior. So if you want a slider, for instance, you can just replicate. If you want to do a knob, you can replicate the slider behavior and just do your own graphics. This is quite a comprehensive drawing API built into it. Yeah. To sum up, I think my experience with using Immediate Mode GUIs in a plugin was a really good one. Like, I really liked the concept, and I still think, like 3 years on, that the code I wrote then was still very clean and expressive, and I felt like I could do a lot with not much code. It was also very quick to work with. And the end plugin that I released was just less than 2 megabytes, and that includes statically linking the runtime library also. So it's very small in that sense. I think number one of this list that annoys me was the text handling. As we saw earlier, the results are not as nice as they could be, and it was just a bit cumbersome to work with. Also because if you want to resize the window, you should regenerate all these font atlases, and that thing was kind of a pain to get to work. And together with that, there's also if you use the docking branch, the multi-DPI support is also not great, meaning that if you move your window from a retina screen to non-retina screen, suddenly all your fonts is a bit more blurry, and like, why is that? And the localization features are kind of basic. Accessibility could be a problem because of the way it handles text, etc. So I think science says that you really regret the things you do, only the things you didn't. But it was, I actually released something, which was a big win. So I finished something, but I also learned a lot about window managers, about threading, like all the stuff I've talked about here. But I think the biggest win with this was it gave me a completely new perspective on how you can write GUIs, one that was not like object-oriented, but more like entirely procedural. So that was maybe the biggest bit. It was still kind of a bit of a passion project for me. So if it had been a commercial project, maybe I would have done some things differently. Maybe I would have used JUCE for like the cross-platform parts and for the plugin, but I still wanted to use Immediate Mode GUIs. Some of the resources, I know that there's 2 libraries for using Immediate Mode GUIs in clap plugins that seem quite like full-featured. There is one project that I found that was using JUCE, but it didn't seem like it was completely finished or anything. I didn't try it actually. And the last one is my own, which is not updated. It still has this, where every instance has its own thread. So I think if you want to use this in a plugin, you probably need to some extent roll your own, because there's not a complete solution yet. All right, that was it. Thank you so much for listening. If you have questions, you can also email me. I don't really do social media that well, but I think LinkedIn is probably the best place to find me if you want to contact me. But yeah, questions. Thank you.